Lesson 78 deals with products of square roots. So we've seen square roots a lot in our bell work, a lot. We've worked with them from time to time in the Pythagorean theorem. And last week we had a lesson on simplifying square roots. So we're going to reintroduce it again today and learn another property. And we're also going to continue simplifying. So if you're having trouble simplifying square roots, today will be a good lesson for you as well. All right, here we go. So what we've got here, we're being asked to simplify this expression. Now the way this expression reads is the square root of 2 times the square root of 14. Now anytime you have two square roots being multiplied by one another, you can just put them under the same square root sign and multiply them. So the square root of 2 times the square root of 14 is the same as the square root of 2 times 14. Now that I can make into the square root of 28. Now, if that were a perfect square like 9, 16, 25, 36, 49, it'd be really easy. Unfortunately, this is not a perfect square. And whenever we simplify an expression like this, we always want to simplify the final radical as well. So I gave you some methods for that last week. One was doing prime factorization and looking for pairs of prime numbers. I'm going to use the other method primarily here today, which is to look for square roots or perfect squares that 28 is divisible by. Now the only perfect square that 28 is divisible by is 4. Okay, so 4 is 2 times 2. That makes it a perfect square. 2 squared is 4. Now 28 is divisible by 4. So what I've done is I've refactored it. It used to be 2 times 14. Now I made it 4 times 7. And the reason I did that is so I can take the square root of 4. The square root of 4 is 2, and the square root of 7 is the square root of 7. So all of these expressions are equal to each other. This one is the only one that's simplified, 2 times the square root of 7. So a little bit of work going on there. Let's go through it again. Same exact thing here with b. The square root of 15 times the square root of 3, I can rewrite that as the square root of 15 times 3. Which is equal to the square root of 45. Now is where I have to think, what is the biggest perfect square? Not just any perfect square. What's the biggest perfect square that 45 is divisible by? It's obviously not divisible by 49. 49 is 7 squared. It's not divisible by 36, or 6 squared. It's not divisible by 25, which is 5 squared. It's not divisible by 16, which is 4 squared. It is divisible by 9, 3 squared. We'll make that 9 times 5. That's 45. And then we'll take the square root of 9, which is 3. And the square root of 5 is the square root of 5. That is a simplified radical. Because 5 is not divisible by a perfect square. 7 is not divisible by a perfect square. All right, now these two, I probably wouldn't take that route. I'm looking at that square root of 5 times that square root of 5. Anytime you multiply a square root by itself, you're going to get the number that's inside the radical. So that would be equal to 3 times 5. Square root of 5 times the square root of 5 is square root of 25, which is 5. Anytime you multiply these numbers by each other, you're going to get the number that's inside. And 3 times 5 is 15. So there is no radical. We had two irrational numbers, and when you multiply those two irrational numbers by each other, we ended up with a rational number. It happens sometimes. Now d, I got the same thing going on. I see that square root of 3 times the square root of 3. And since multiplication is commutative, I can do it in any order I want. I'm going to do just that. I'm going to multiply this 5 times 2 first. And I'm going to call that 10. And then I'm going to do the square root of 3 times the square root of 3. And I'm going to call that 3, because it is. And 10 times 3 is 30. All right. So we've done this kind of stuff before on an in-class activity. We're going to find the length of a side of the square with these vertices, and then we're going to find the area of the square. So the first thing I'm going to do is graph this square. So we got 5, 4, 1, 5, 0, 1, and 4, 0. And there's my square. I'll box it in to show that it's a square. Okay. And then I'm going to find the area of this square. Oh, no, I'm sorry. I need to find the length of the side of the square first. So how far is that? Ooh, well, I know it's longer than 4, but I don't know how much longer. So here's what I can do, though. I can look at this right triangle, And I could say, okay, there's the legs, A and B, and I'm trying to find the hypotenuse, C. Now the legs I know that A is 4 and I know that B is 1. So 4 squared plus 1 squared must equal C squared. And once I get it down to here, okay, the square root of C squared is C and the square root of 17 is the square root of 17. I'm just going to leave it just like that. So the length of the side of the square is the square root of 17. Or the square root of 17 units. Okay, it's an irrational number, so if they don't want it rounded, I'm just going to leave it as the square root of 17. And by the way, 17 is not divisible by any perfect square, so no need to simplify it. Not that I really want to anyway, because the next step is to find the area of the square. Well, the area of a square is just base times height, and in this case, the base and the height are both the same thing. So I'll do square root of 17 times the square root of 17, which is 17, because anytime you multiply two square roots by themselves, or by each other, or a square root by itself, you get the number that's inside the square root. So we'll say 17 square units. And that's how many square units are in here. Let's do that again. Find the area of a rectangle with these vertices. So it's not a square this time, it's a rectangle. But I'll plot these points, 0, 5, 3, negative 1, negative 1, negative 3, and negative 4, positive 3. There's my rectangle. Now I need to find the length and the width of this rectangle. So I know that one is 4 by 2, and I can find C. So let's do that. 4 squared plus 2 squared would be C squared. I'm going to leave this as the square root of 20. That can be simplified, but I'm not going to, well, I could simplify it. I'm not going to do it right now. Maybe I will. And then we got another one. We need to find this length, so it's 3 by 6. So how about 3 squared plus 6 squared is would be C squared. So that would be 45 is C squared. So C would be the square root of 45. Not going to bother simplifying that, but I could. Actually, yeah, let's do it. Let's go ahead and simplify it. Let's make that the square root of 4 times 5, which is 2 times the square root of 5. And let's make the square root of 45 the square root of 9 times 5, which is 3 times the square root of 5. Now, for the area of this rectangle, we need to do length times width, or base times height. So I'm going to do 2 times the square root of 5 times 3 times the square root of 5. 2 times 3 is 6. Square root of 5 times square root of 5 is 5. So we get 30 square units. So we have these irrational side lengths, 2 times the square root of 5. That's how long that is. And 3 times the square root of 5. That's how high that is. It ends up with a rational area, 30 square units. A little bit of work going on there, but it's all work we're capable of doing. We can do Pythagorean theorem, and now I'm teaching you how to multiply square roots. So, describe 2 ways to find the area of the shaded square. One way using radicals and one way without using radicals. Okay. Well, the way using radicals would be what we just did on the previous 2 examples. We could, so here's method number 1. We could find the length and width of the inside rectangle. It's a square, but whatever. You could just say of the square using the Pythagorean theorem. Then we would just multiply that length and width to find the area. I should say then. Then multiply those dimensions and we'd have the area. Or method number 2, some of you have done this in class before, would be to find the area of the whole big rectangle here. Then we would need to subtract the area of these 4 triangles outside of it. So if we found the area of the whole thing and then subtracted the area of each triangle, we'd find the area of the shaded portion as well. So there's two different methods. This one, the first one would use radicals, the second one would not use radicals. Now, which one's easier? That's the question that people probably want to know. So I've gone ahead. They didn't ask me to actually find the area, but I'm going to do it both ways. So number one, I'm going to do 1 squared plus 2 squared equals c squared. So that'll give me 1 plus 4 equals c squared. 5 equals c squared. So the length of the side of the shaded rectangle is the square root of 5. So I'll just do square root of 5 times square root of 5. And that is 5 square units. That wasn't that bad. 5 centimeters squared. Now the method number 2 would be to do the area of the whole rectangle. That would be 3 times 3, which is 9. So it's actually a triangle or square too. And then find the area of a triangle. So 1/2 of 1 times 2, or 1/2 of 2 times 1. And then we'll do the whole area minus the 4 triangles. So 4 times 1 is 4. And we still get 5 centimeters squared. So you get the same answer either way. So one uses radicals, one does not. Which one's easier? I don't know. Neither one of them's that bad. Just depends on which way you want to go about it. Or maybe how much information you're given. So that's all I've got for you today. So we did some simplifying radicals today, some multiplying radicals, and then simplifying. And we did some work with area as well. All right, have a great day, and we'll see you soon.